Hello and welcome. I'm Bill Wake. We're starting a new project today. I'm calling it Swarmed. It's an old BASIC program from the 1980s, and we're going to transliterate it into Swift and then refactor it, modernize it, and see if we can make it work in a more modern game environment. So the game looks something like this. You've got a ship in the middle and a bunch of stars out there, and you can move your ship left or right, but not up or down. And you're trying to navigate through the stars and not hit anything. And as things go, the number of stars increase and so on like that. So standard, make it harder stuff. It originally ran on an OSI Ohio Scientific computer, which had 4K of RAM and an 8K basic ROM. So it's a much smaller than machine than we're used to, and it's in BASIC. So this is the original code that we're going to be working with. It's these old basics, man. They're pretty pretty hard to look at. One thing is they don't need spaces in the line, so you got to get used to picking out the words in the line. But basically, it sets up the ship and sets up this loop of waves of aliens, and or which are stars, I guess. And then at some point, line 110, sort of where the star on the right hand side is, it's poking 23 times random. Well, 23 is the screen width in the old machines, so it's basically filling random stars on the bottom row and then scrolls it up as it goes. And the whole thing was built around that. My friend Bill Mays found it in an old magazine. We used that for inspiration and built up this whole thing. Original was a one-liner, and that line was the heart of it. Let's see. So there's more, and we'll go through in more detail, but I don't know if you see peeks and pokes in there. That's the old way to access the screen. So back in the old days, they just did memory mapped I/O. So they would just dedicate a region of the screen, and if you put a byte there, it turned into a character, and that's how you got it there. No indirection like we're used to with all these modern libraries. All right. And I don't know. It's a page, a good solid page, but not much longer. So about 50 or 60 lines, I guess. We'll look at the details later. All right. And then I found a couple of reference manuals. So on the left, the basic reference manual. So what's this basics, syntax and everything. And then on the right, the character graphic manual that tells you things like, hey, what is character 226? Because it's not whatever you would think it would be in ASCII. They had their own character sets back then too. All right. So the plan I've got is we're going to transliterate BASIC to Swift. All right. So we're going to take the BASIC program, turn it into a sort of a, I don't want to say interpreted, but sort of a line-by-line transliteration with a mechanism to transfer between lines. And we'll do that in Swift. If you have been following me for a while, way back when I had a maze program that was very similar kind of in concept. It was an old BASIC program, lots of go-tos, lots of ifs, and I transliterated it into Java in that case, and you could work to make it a structured program. Then we're going to do some work to simulate the environment. So we need at least the screen, so some sort of way to print out the characters we're going to look at, and something like the keys, and I'm really not sure how to make that go. We'll see what complexities there are. Once we have that together, then we can run this thing, and then we'll refactor it. And once we've got it into some sort of reasonable shape, we'll see if we can modernize at least the I/O part of it, and see if the result is worth anything to us. When you get fun out of refactoring, that's probably where the most of the fun is. All right, now I went through the manuals and I pulled just anything that looked useful for us. So I'm going to share a few reference pages, and we may have to dig back to the manuals later. But this is the character set. So 32 is a space, 33 is exclamation, 42 is a star. That's all standard ASCII kind of stuff. Same thing for 48 to 57 being the numbers, and then the letters 65 and up. This program only uses B, M, and O. And then a couple other things. We'll actually use this 238, the little airplane kind of thing. I've also got an old breakout and clone of the commercial idea. Well, clone's a little strong, but it's going to use the ball and the squares and the sidebars and stuff. So we'll see that on another voyage maybe. All right. So if you poke 238 into a certain memory location, it puts a ship on your screen. So we'll take advantage of that. All right. Then the screen. Oh, what a mess. These old things, well, they were version 1 is all I can say. So what they did is D000 in hex, or 53248, is the first screen memory location. But because well, TVs in those days had pretty limited bandwidth, and um, the circuitry they wanted to use, they didn't want to pay for the good stuff. So normally on a TV monitor, you would only get either 20 or 40 characters across. This one kind of has a compromise. It uses 32 characters for a row, but it only shows the first 20, the 24 out of the middle. So D083 is the first visible character. That's down a few lines from the start and over a few columns. At the way the game works, the row 53509 to 5330 is where the ship is going to show up. And then I think that last one, this row 54085, I think that's where the stars will show up. And then D7DF is the end of the screen space. So I think that's a 4K. No, is it a 1K RAM? I'd have to, whatever it is. 32 by 32 or something like that. But we only get about 20 something by 20 something. All right, now I've got a map from the manual, and this one is for showing you the 24 by 24 screen that we'll be using. The ship there in 53509, I colored it pink. The stars in that last row, and then we get hex addresses for all the others. And let's see. So yeah, we'll have to make use of that at some point. This is reference. Now the keyboard is amazingly painful too. And you're probably used to plugging them in, or they're built in, or USB plugs or something. Back in the day for these, the way they did this is polling, and so they arranged the wires to come from the letters in a grid. So you had rows and columns, and then you connect those little triangles that kind of connect them, let you tell if this particular one got pushed on or off. So to find out if A was hit, you would go to R1, row 1, down on the bottom, and you would look in column 6. And if you asked for row 1 and looked at column 6 and that bit was set or cleared, it would tell you if that key was active or inactive. And so you really, yeah, I don't know. What it looked like in the code to me, it looked like we're going to be using B and N for left and right. And I don't know. We'll see what comes of that. But it looked like what you do is you peek and you poke somewhere to say which row you want, and then you peek and ask which column is active, and you AND it to see if it's there. Okay, let's get to code. All right, so all I've done is I created a new project. I copied in the basic code that we'll be working with. Yeah, that's the code we're looking at. And I created a logo, which is that ship. And I defaulted some unit tests that are just an empty set of tests. Okay, and I ran those painfully slow. And I don't know why it reset my iPad to iPod Touch, but that's what we were apparently working on today. The test is just out of the box, minimal. Just, this is a pretty bare project. Okay, and then the way this works, if you haven't seen Swift before, well, they have this notion. They're changing the way they do UI, and they're going to a more declarative textual based kind of way. Um, they've also added this thing to let you create an application. So the application, you create a scene, which is a default class, window group, which is a standard class. Excuse me. And then in there you call the content view, and the content view is the code we work with. So it's what's showing up. I'm gonna hit run. And we'll just see a hello world kind of thing, but we can see it there. But the text that we put in there is, that's the object that it puts up, and it has defaults that say, hey, if you're in a view, and why don't you just center it by default and stuff like that. Okay, there we are. Yeah. All right. So this horrible code. All right. So the plan of attack I have is I'm going to create, basically I'm going to create a loop that is the line number counter, and we're going to transliterate our code a line at a time, define the loop, define the line number. And so if you fall through, like look at line 35, line 6 of the code, but line 35 in basic. All right, you finish doing these assignments, and then you go to line 50. So there's an implicit go to 50 on the end. We'll have to be explicit about that. Okay, and for loops and go sub, they're more complicated, and we'll tackle them when we get there. But let's see what we can do. And so I'm just gonna. I don't want to say mindless because I have to be aware. So I'm trying to train myself to say mechanical, but I'm going to do a very mechanical transformation. Just convert and copy, and I'll minimize anything I don't know how to do. I'll just kind of defer, like print. We don't have a screen, so I'm going to get the code translated and then work on getting a screen. And these peeks and pokes, that's definitely later. But we'll do it and print. Yeah, more prints. Okay. But let's start with that. Okay, and I don't know how to. I'm not sure what I want to do to test this, but let's make a group that's. Well, no, let's just start with a file. Okay, and I think we'll just call it Swarm. It'll be a Swift file. Swarm, okay, and I'm just going to make a public class Swarm. And we're going to give it a method that's, well, it might even be static. I don't think it has to be. Let's just call it run, and it produces nothing, and here it is. Okay. Now the overhead I'm going to have to keep track of this line number. And in the basic, let's see if I can split. I don't remember how you do this. I thought there was something on the menu. No. Okay, well, I'll bounce around, I guess. That's just the way it's going to be. All right, so I don't have anything called lines, so I can use that variable, and we'll just let it go. So this is a var. Line is an int, and start with 0. All right, the core of this thing is going to be a loop. And we're going to let's start this line at 1. Okay, so what I'm going to do is while line not equal to 0, I'm going to do stuff. And so far, all I'm going to do is default. And this is really line, line. My keyboard is going, can you tell? Okay, we're going to add 1 to line. If line is greater than 10,000, which we know we'll never hit in our code, we're going to set line equal to 0. Okay. And, oh, this should be a switch statement, yes. Okay. Now, is that legit? Switch on line. Okay. So what I expect so far is we're going to start at 1, and maybe I should even just be explicit here just to kind of convince myself. Okay. So I'm going to start at 1, and I'm going to keep going, and eventually I hit nothing, you know. Okay. So this is kind of a bare minimum type thing, I guess. Okay. Just my little structure of a framework for my code that's going in. Okay. Now let's translate some lines. I'm going to leave the comments, and let's just take line 35. Okay. So the way we translate this is I'm going to put case 35, and then I'm going to assign these variables. Well, the variables are SC, and I'm going to assume they're ints until I find out otherwise. And I'm going to default everything to zeros, just as sort of reasonable defaults. Okay. Oh, let's put that inside the switch, shall we? Okay. And the end of this thing is a break. All right. So what's the code? Well, it basically is the code. Colon here says I can put multiple things in one line, which is kind of a fancy basic thing. The even older basics didn't even do that. So I've got these variables. I've initialized them. Okay, so I'm going to go into mechanical mode here. Anything I can do as easily as that, I'm going to do it. Anything I can't, I'll kind of find a minimal step through. Okay, case 50. Oh, and we also have to set up our fall through. Okay, so I'm going to say go to and 50. I'm looking at the code saying line 35 is followed by line 50. All right, and we need the go to function. Target. Okay. Okay. So I've got a go to now. Case 50 must have one executable statement. Well, it's going to have a break. Okay. And then looking at it, the next line is 80. So we'll do go to 80 here. All right, and we'll take these lines. Okay, get a problem with declarations. Int equals 0. Now these could be floats, and if they start acting that way, we'll adjust. Okay. And I'm going to look again. Following 80 is 85. Okay, and we'll say poke SP238. That function's undefined. Okay, and I'll just do a print. Okay. Gotta keep my case consistent. Basic is case insensitive, but these old machines, they made it so hard to type lowercase letters, and some of them couldn't. We'll just say at. Okay, poke at somewhere with value. All right. I'm going to grab a chunk. I'm just trying to speed this up. Okay, for 85, case 85. Okay, well, let's see. So for loops, for loops in BASIC are kind of complicated, but this is a special case that we can just easily do. So basically, you can nest for loops, and you have this next, and you can optionally say the variable at the end that tells you which loop is closing. Now this one, we can see it's all one line. It's just doing 24 prints, so it's basically doing a clear screen. But let's go ahead and do it. The other funny thing is, I think this BASIC always executes at least once in a for loop, so you can't use it as you will execute the code the first time. So odd, I know. Okay, so let's just do for well, one, and it's inclusive, and we'll just make up a print. Oh, I may have to look these up. I don't know, maybe I have to, I'm kind of mixing. Okay, well, we can do it that way. I don't know, can I say var in? Well, let's do it this way. Okay, and I don't care about the argument. Okay, and print. Well, we will see. Maybe we need to be more explicit here. I'm gonna assume a capitalized one, just so we keep straight the basic one. We'll work on it at some point. Okay, just so we see something going by. Okay. The next one, mm equals 3. And I'm using the fact that we don't really reference the variable. I don't I don't think we ever reference KK again. I should check that. Uh, it's its own. Okay, yeah. So we're okay not referencing that. So I'm taking a special case rather than get the full complexity of for loops. Okay, line 93, case 93, mm = 3, go to something and break. And this one we forgot the go to. 93, right? Okay. This one is 95. Got to declare variable mm. Okay, now we're getting a little more complicated here. For n equals 1 to 10, we're going to have to figure out, we're going to do these analyses all the time. Let's see. And I did some in here. I didn't mention it, but these annotations I was doing, I was kind of showing the loop boundaries and stuff like that. So you can see 95 to 130 is the next NA. That's that loop there. So that's pretty good. The only place it exits is 125. The go sub is fine, but 125 can go down to 200. Okay. And then goes back to 150 and back to 95. So it's a little complicated. But if it's 95, it's going to start over on the next loop. So I think we can just write this loop directly. Well, I'm not sure the right way to do it. Okay. I do have a scheme for a generalized loop, the for loop, and basically you have to put variables on a stack and all this stuff, and I don't want to do it if I don't have to. Let's just, I don't know. This is where I'm going off this mechanical thing. I'm gonna say let's be slightly less mechanical. Let's write the for loop. Oh boy, I don't know. The more mechanical way would be translate this to like for goes to for loop with NA and 1 to 10 and so the thing I have in mind that I think covers the semantics is it's sort of a stack-based approach that when it sees the for loop, it sets up the stack, and when it sees the next, it handles the counter and then decides whether it should keep. If it's done, it pops things off the stack, and this way you can have nested loops that work okay. Maybe we can just defer it. And we'll just call the method and assume that it can do the for. All right, so I'm possibly, I don't know. I'm certainly wishy-washy on it. I'll give myself that much credit. Okay, so what we're going to do is case 95, and I think I can just say for loop with address of NA. I think we need the address. Let's declare NA. Do we have it yet? No. Var NA int equals 0. Okay. 1 to 10, step 1 is implicit, and if we want to execute the loop, we want to go to line 96, and if we want to exit the loop, That's going to be trickier. Exit the loop. Where's NA? Well, the next line after this NA loop is 141. Okay. So I'm providing enough information so that when I start this thing, I can set the line number to 96 if it's supposed to execute, and then I'll push all this on the stack, and when it's done, I want it to go to line 141. Okay, so let's make this method. All right, and it's going to take, I don't even know how to even write this. It's the, can I do address? This is the variable whose type is address of int, I think. I never write pointers in Swift. This is like a new thing. Yeah, apparently. Do we put them? I don't think we do that, do we? Is that how it goes? Okay, I gotta look. Well, I can get the strings. Unsafe pointers. I don't know. Well, let's do the string. We'll trust there's some sort of reflection, and then I don't know. Maybe I should be explicit. Variable NA, start 1, ending at 10, skip 1, loop 96, exit 141. Variable start of int, ending int, skip int, loop int, exit int. Okay. Okay. And I'm going to say, well, the semantics of this thing that it always executes once, we'll just, we'll say then we're going to go to the loop. Okay. And so that takes care of the go to for this one, but not the break. Okay. All right, case 96. We will say poke 54156 LA plus 47. and poke 54157. Whoa. Seven NA plus 47. Now, I think those are in screen range. I don't know where they go. Okay, but we'll go to line 97 and break. Okay, we've got another for loop. Variable is LW. 1, 2, 20 plus 5 times LA minus 1. Skip 1. The loop will go to 100. The exit, I don't know. You don't really know that at this point. Yeah, I don't think that belongs on there. Because you legally could have lots of different exits. So we'll take this off. Okay. And break. 100 print. And he needs to go to go to 101. Okay, 101. In this case, it needs to be an else. 102. That's our first if statement. NA we already declared. Yep. Okay, this is another one. This one's a pure delay. Okay, so 102. I'm going to use my knowledge of that. I'm going to delay 30 and go to 105, break, and delay. We don't have yet. And we don't know how long 30 is. So this is, it's just a loop to pause 30 somethings. It's probably, I don't know how many statements you get in a second, but I'm guessing it's probably a fraction of a second, maybe a third of a second. Would that be good if it was 100 100ths of seconds? I don't know. Basics weren't super fast in those days. Okay. 103. Okay. 105. All right. Well, we've been going a while. Let's take 2 or 3 minutes. We'll come back and we'll see if we can finish transliterating this thing and then try and make it work. All right. See you in 2 or 3 minutes. Hi, welcome back. All right, let's keep going. Okay, now this one, we can see the next is on the same line as 110, so um, we can do this directly. Okay, so let's see. So case 110, and this is 1 dot 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 na inclusive dot for each, and we do that. Okay, x then is not referenced in this. Whoops. So we don't need to use it. All right. And then we're going to do a poke ll 23 times rand of r. Okay, r we already declared, rand we have not. And this is a random number thing, and I'm going to have to look up the semantics when it's time for that. Int, I think R was declared up here somewhere. R is 8484. Oh, it needs to return an int. Well, it does not return an int, in fact. It returns a float. Okay, now we're going to have to be a little... Let's just return 1/2 consistently. Well, maybe 79. Oh, 42. Why not? Okay. This float has got to be, the result of a random is 0 dot dot less than 1. So it's between 0.0 and 1.0, but it doesn't, it's closed on the left. In other words, it could be 0, but it's open on the right. It cannot be 1. Okay, so this, I think we're just going to say int of that. Okay. And so what we're seeing here is, since this is 0 up to but not including 1, this is 23 times 0 is 0, up to but not including 23, if it turns out to be almost 1. All right, so it's 0 to 22. It seems a little odd. 24 characters per line. Maybe we have some borders or something, but this is basically poking. Oh, this is LL plus that. And then what are we poking in there? Well, we're poking 42. And if you've read any Douglas Adams, you know it's the meaning of everything. It's star, representing everything. Okay, so we're pushing the stars on this line at random positions on the line. It could be duplicates. You could get the same number twice in a row, 7 and 7. So it's going to be at most 23 stars. 0 to 22, so there are 23. Yeah, seems off by 1 to me for some reason, but okay. But that covers us. We need a go to. The go to is 120 and a break. Okay. Let's see. Now, I think that one covers that one. Okay, go sub, that's a new one. So go sub. I'm going to say go sub 2000, but then I know the next line number, which is 125. So you go to the subroutine, you do your stuff. When you come back, I want you to send me to line 125. Okay, and there's going to be a stack involved, but we're not going to implement it yet. Okay, so function go sub, and it's subroutine is an int, return to is another int. Okay. And I don't know, maybe I should make you be explicit, but I'm not going to. Okay. And it builds in where it's going to next, so we don't have to. Oh, I guess we should at least make it do the line equals subroutine. Okay, so we'll make it. We don't want to get stuck on a big loop. Okay, if now I think the semantics of this one is not 0. Hey folks. All right, case 125. All right, so we'll just assume that's it. Low is not 0. Then go to 200. Else go to 130. Okay. Now 130, we're at the bottom of these loops. We have the LW loop starting here and the NA loop starting up here. We're trying to close both those. And whoops, LO is not defined. All right, let's make it. Okay, so now this one, case 130. Oh, I'm sure I typoed that. Okay. We will say next loop, and I'm again making this up. Where should you go when you finish? Well, the variable is LW. And if we're done, well, this is a little tricky. Now we've got this line 130. Hey, folks. Okay, so line 130, but we want to return to handle the next NA if it's done. So I'm gonna make an artificial line number. For this one, and I'll just do negative so I know it's kind of artificial, but it's the target of the NA. So the loop, it's going to look on the loop stack to figure out where it should go back to if it can, but if it can't go there, where should it go? Well, it should go to minus 131. And let's give that exit minus 131. Okay, and I guess I'll be explicit here too. Variable. All right, so I'm saying you're going to look on the loop stack and decide where to go. So function next loop, variable's a string. We haven't dealt with the reflection or how we're going to get there. And the exit is an int. And for now, we're just going to print next variable exit to exit. Okay, and we'll just hard code the assumption for now that it's going to go to the exit. Okay, so we're saying our loop's only run once, and that's the way it goes for now. Okay, so this is the next NA. Next loop variable NA exit to, well, we ran out of stuff here, so let's pick up this 141. Trying to decide a good block of stuff. Okay, exit to 141. Okay, break Okay. 141, straightforward. Case 150. Greater than 0, go to 95. Otherwise, go to 160. Okay, so this one is case 160. We're going to poke 530, 0, and we're going to end, which is really saying line equals 0, which will kick us out of our loop. Okay. All right, this one looks very similar to the one above. It's the loop to print to clear the screen. Let's see, where'd that one go? There's a print. Oh, I thought we had one that did this already. No. Okay, so 205. Okay, so we'll do 120 for each. I don't need I in the body, so nothing in. And then all that goes on here is this print. And you can see there's redundancy here. This thing is going to 210, and then 210 goes to 150. Like, you could have gone to 150, you know, and that's fine. We'll take care of that after we get things working. Okay, so now we're at 2000, and if you remember, this is the subroutine. Now we don't know what the subroutine's doing yet, but we know it got called. So, all right, so it's same as always. Okay, and poke 531. One thing I know is 530 is this turns on or turns off the basic language keystroke handling. So if you hit Control C, normally basic will interrupt, and in this case, I think you're turning that off. Maybe you're turning it on. I have to look. Okay, but in any case, and then we're pushing something onto the screen, I think. 55. I don't think I kept track of that one, but anyway, next line. We're in this section. Okay, next line is 2010. Okay. We haven't got a peak statement yet, but we'll get it soon. Oh no, this isn't screen. This is that keyboard matrix. So you're telling it, I want you to look in all rows of the keyboard. Definitely low level stuff. And then the peak is going to read it, and then we'll decide which row is active. Okay, so function peak takes an address, of int, and it returns, we'll just say an int, even though it's really a byte. And I'll just hard code it, but maybe we'll give ourselves a little notice that we got into peak. Okay. We don't have x yet, so let's make that variable. All right, and we'll go on. Okay, something happens. We go to 2040 and break. Okay, whoops. Okay, case 2045. Not 32, then, whoops. Go to 2100. Otherwise, fall through to the next line. Okay. 2050. Poke SP238. That's the ship. And then we're going to do a return. I'm just going to assume a function for that again. Well, it's not going to work for now. Okay, it should have a variable on a stack somewhere. We haven't defined that yet. Oops, it's this thing. 2100. Poke SP -1 gets 66. Poke SP gets 79. Poke SP +1 gets 79. And then we need to go to. All right. Do the pokes. SP plus 333. Go to 2106. All right. In this one, we can see it's another one of these delay loops. So we'll delay 250. And afterwards, you need to go to 2107. Okay, so print does not take a string. Let's give it one. And we'll just be a little noisier than we should. Okay. Another delay loop. Delay 500. So it just printed the scores and then it waits 500 ticks. Half a second seems like enough. Maybe it seems like probably a second. So I'm thinking each one is worth 2/1000ths of a second. Go to 2110 and break. Oops, need a case on there. Ooh, is that minus? Yeah, I don't think these basics had the C-style decrement. I think this really is assigning that. Okay. Okay. So that to me is the basic transliteration. So I've just turned everything into variables, and I've got a few helper functions for for loops, go sub, return, print, random, stuff like that. So let's save this. And I'm saying transliteration. Okay. All right, so I'm going to go make sure there's no more of these things. So our check is everything needs to start with a case and end with a go-to explicit or implicit. So let's just walk through, make sure everything seems legit. Okay, so it's case go to, case go to, case go to, case go to, for loop. All right, so we're assuming our for loop will do the go to the loop start, in this case 96. All right, pokes go to, again the for loop should go to 100. Yep, 100 just does a print, goes to 101. All right, each branch ends with a go to, delay and go to. I was worried about that one. Go to of hand coded loop with a go to. The go sub will go to 2000. Go to on both branches. Next takes care of a go to. Next takes care of a go to. Oh, missed one. 141 should go to 150 and break. Let's check the real code for that. 141. Yeah, should fall through to 150. And maybe I should have made those go-tos called fall through or something, but all right, 150 go to on both exits. This does a line assignment, which is really go to 0. Let's do it that way. Another missed one. Let's make sure 200 goes to 205. 200 falls through to 205. Loop followed by a go to. Go to needs a break. Go to break. Break. This needs to go to 2030. This falls through 2040. Falls through 2045. Falls through here. Does it go to one or the other? Poke. Poke some stuff. Oh, return. We probably should put a break here. But return is intended to deal with that stuff. Go to, 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 go to. Return has its own, and I guess we can break here, but it's not going to hurt anything. All right. So we fix missing go to or break. All right. So we're kind of halfway acting like a compiler in a sense. I mean, hopefully it's a smart compiler, but the implicit fall through I'm making explicit here. So that should be okay. Okay. Now, I don't know if I should be like, should I be test driving something? It's kind of weird that I don't. All right, so go to does the right thing. That one's ready. Poke, we haven't defined the system we're working with, so poke does not mean anything. Same thing, we don't have an IO system or any of that, so no memory, no IO. We'll just let those be at this level. Okay, for loop. Okay, maybe body would be a better name. I don't know. The for loop, we're just saying we're just going to go there. We haven't done anything about it. And maybe that's the place I should figure out. So the semantics are supposed to be the first time you see it, you should set the variable equal to the start. push all this on the for loop stack, and then ending skip. Oh, the skip is an increment. Okay, but yeah, go to loop. So we need to get from the variable back to the item. Okay, so let's see if there's a cheap reflection in Swift. I've never used it, so let's see what we got. Okay, we got a couple of things. We want to reset them. Mirror reflecting self. Create a mirror, then the mirror's child property will iterate over the stored properties. Child.value. I don't really need to iterate, but let's try this. So this thing, okay. I think I do want a little bit of a test on this for loop stuff. What would the test look like? I guess I would have to have a variable. Yeah, let's attempt that. I don't need the setup stuff. Oh, I didn't use John Reed's test case generator thing. That would have been smart. Okay. So we want to make sure that a for loop sets the initial value, I guess. All right, and we're going to make a swarm. Swarm equals swarm. And if I call is that not what we called this? Class swarm. Swarmed. Swarm. Let's build. Okay, good. All right. Let's assign SC equal to 100, and then let's make a for loop. Variable is SC. Start at 10, ends at 25, 15. Skip 1, and the loop should go to let's say this goes to 110. Well, let's just make it different so we can tell. Okay, so if I execute the start of a for loop, then I expect that swarm.sc should be equal to 10. So it should start the loop at the starting value, and I expect that the line number should be 777, where the body is. All right, this test will fail. At least I'll be shocked if it doesn't. It might pass the line 17, but I don't think it's going to pass line 16. All right, are we starting? Yeah, okay. I don't need a break here. Okay, yeah, so the assert failed. 100 does not equal 10. All right, well, we're due for another break, so let's take 2 or 3 minutes. We'll come back, get this thing passing, and then handle the next and see if we can make some more progress. All right, see you in 2 or 3 minutes. Hey, welcome back. All right, so we've got this test failing. Let's get for loop. We need to look up the variable and make sure it set its starting value. So let's see if we can do that with this mirror thing. Where's Swarm? Here we go. Okay, so for loop. So we're going to do mirror reflecting self. Now we can say mirror dot what's children? A collection describing the structure of the reflected. Oh boy. All right, what is this doing? Child.label. Child.value, but I'm not seeing anything that lets me change the value. Is that going to give me... Okay, now let's see if I can do it. Air variable dot value. Can I assign it? equals start cannot assign property. As a let. Oh. Our variable was written to, but never read. I don't know if that's a problem or not. All right, let's see if this works. I don't have a really good feeling about it. I just can't tell if you're going to sign through that value. Nope. Okay. Maybe we'll find something else. Switch reflection. Set value. And that's what I want. Reflect returns mirror. Get the mirror type with reflect. Okay, that's a lot of work. KVC is Objective C, yes. Property info.set value. That's .net. Okay. Swift reflection is easy. I don't want to go to I don't know. There are worse schemes I can do. Like somehow I have to get between the string name and the value, the variable. You can't write properties. Okay. Still quite powerful. Yeah, well. Okay, so that's not going to work. All right, my next theory, and again, I don't know how to do it. Okay, we know mirror won't work. All right, my next theory is I want to pass the addresses of these ints. So we started to look at it, and I kind of gave up. Trying to think of a class that passes the address that I could steal from, of course. Swift pass address to function. In-out parameters. It's not a real pass by reference. No, it is not. Yes, see, we'd pass a pointer. Well, I know I pass the address of things around sometimes. I don't want to use NS values. Oh, well, that's arrays make copies, so I don't think we can make that work. Yeah, it's nothing they're encouraging. Searching up a pointer, yeah. How about unsafe reference Swift? Really, I want to get rid of the use of this for loop method, but I get it. I'm putting it in there so we can just start with the bare semantics and then go. So, all right, pointers in Swift. That looks like C. All right, pointers. Unsafe mutable pointer. Where's the bind? Pointer equals raw pointer to bind memory to int self with capacity count. Well, Can I put these in some sort of index or something like that? So I guess I'm trying to think of like, could I make some sort of hash structure dictionary that mapped my value All right, I'm going to customize this to the things I have. So NA, I definitely reference the variable elsewhere, so I can't do nothing. What I'm thinking, let's see, loop vars is an array of int. I don't know. So if I was going to try and do something like sc address equals 0, or NA, I guess we saw NA. NA address equals 0. So one thing I could do would be keep the variables in an array, at least the loop variables, and then reference them through the array when I want to get to them. I don't know. Let's see what that looks like. Okay, so now I'm going to pass NA address. There's the next. Okay, let's see what we can do here. This is now an int, and next is now an int. Okay, who's complaining? Probably the other loops. Yes, so this should be LW address. And this should be LW address. Okay. Boy. Yeah, Swift is, I don't know, it's kind of like more, I think of it as more Java-like than C-like, but they've gone further. They've tried to use a lot more like value types and things like that. I'm not demonstrating much of that here. But they don't have pointers, or they barely have pointers, maybe I should say. And there is, like, it looked like it's interoperability, so you could pass stuff to C, but I'm going for more of a homemade pointer at this point. So what I'm going to do, I'm going to see who uses NA. All right. And anybody who uses NA, they really should be using loopvars sub NA address. And then maybe at some point that will become NA. But somebody should be complaining. Okay. So I'm saying to access NA, you need to do loop vars sub NA address. NA loop var sub NA address not equal 1. Okay. Whoops. Okay. Now nobody's referencing an A anymore. Okay. And then the second one was LW. LW. I don't see that here. Where's LW? Oh, so I never had that variable to start with. Interesting. Oh, nobody references the variable. Okay. Okay. Now I think I can make my test pass. Okay, so what I'm saying should happen is that loop vars of the variable should equal start. That's step one. Okay, so if we set the variable to the start and we go to the start of the loop, basic ones always execute at least once, so we're okay. All right, and I think my test will pass. Now, the next case is going to be trickier. Nope, somebody's string worm dot. Oh, this has to be. Well, let's use NA. All right, I think it will. Swarm has November loop var. Loop vars. Okay. All right, let's try again. So I'm saying we have to do indirect addressing to get the loop stuff working. Yuck. Excuse me. 0 is not equal to 10. So that looks like we did not update in the for loop method. Or it didn't stick. Oof, loop vars. So one of the things that Swift does that's different, really different, it copies arrays instead of updating them in place. And when you do update them in place, I don't know how I mean, they've got fancy stuff behind the scenes to make that reasonably efficient, but it means sometimes you get copies of stuff and you haven't updated what you thought you would. Oh, now I'm still running. Oh, I don't want performance. No, we don't want that. As a matter of fact, I don't think I need UI tests at all. Well, I'll just comment them out just to. Well, what's the real way? It's the scheme. So I will not enable these. Okay. So it's got the 0 when it looks up address 1. All right, I think we're going to take a look. Oh, I didn't check my scheme. If I had the debugger turned on? I do, apparently. Okay, so let's print variable. Should be 0. Yep. Okay. And if we print loop var subvariable, it should be 0. Ooh. Loop var subvariable. Wait, what? Oh. My test set it up. Okay. Loop var subaddress is 100. Okay. So when we step over, we expect it to turn into 10. Okay. Let me just keep going for a bit. Okay. How did it fail? Oh, SC. No, this needs to be swarm.loopvar sub swarm.na address. Okay. See how easy it is to blame the semantics when you screw it up? Now that should pass. Okay. So what I proved is you can get the variable back. You will set it initially. All right, the other thing that's supposed to go on is we need to be able to stack these things. But maybe we don't. We're explicit about the loop exits and the variable we're looking at. I think maybe we can get by without this. No, we need to know the end. We got to keep that stuff somewhere. Okay. Well, let's do the simple for loop. Let's do the next, and then we'll extend it for the rest of this. So, test next. Increments value and repeats loop. Okay, so I'm gonna have to do something like, you have to do the for first, so this is all set up. Swarm, and I'll just mix it up a little bit just to make sure everything's good. Let's start at 2. Let's skip 3. End at 15 is fine. And we'll loop to 101. Okay, so I set up a variable. I started a for loop. So I don't even need this 70. That's redundant at this point. Okay. Before I needed it because I wanted to be sure that my for loop was overwriting the variable that already existed. All right, now when I do next loop, okay, my variable is swarm.na address. My exit is 200. Okay, and I'll assert equal. Well, my variable, which is swarm.loopvar sub swarm.na address, my variable's value should be 5. It started at 2 from the for loop, and then we incremented it, and it should go to 5. And then it should be ready to repeat the loop. Swarm.line should be the loop 101, not the exit 200. Okay. We'll run this test. I'm pretty sure it will fail. Making it pass is going to be a bit more work because we need the information here, ending and skip and loop, and we don't have it. Okay, so we did not increment, and we set the loop to the fail value. Okay, so let's go back here. Oh, there really is a stack of these things that goes on. But I could imagine, I don't know, could I have parallel arrays? Is that too stupid? Okay, so next is really supposed to increment. Let's see, it should increment and then test whether it's done and then decide where to go. Okay. So I don't think... And if we use a stack, we got some stack discipline to deal with. Okay. The variable index we know. We don't care about the start because that's only at the beginning. We need the end, the skip, which is the increment, and the loop. All right. Well, I think we are going to have to stack these things up. So we got to put them somewhere. Now, back to some of the key value pair. Yeah, maybe we should. Maybe there's a dictionary or an array. We need end. We need end, skip, and the go-to place, the target, loop body. Okay, so let's deal with that. The loop stack, and this thing is a triple. It's the start and end, and another target. Okay, yikes. We'll refine it. Not in the next 2 minutes, but we'll refine it. So I'm saying when you start a loop, you really need to push this stuff onto the loop, and then the next can pop it off. Okay, so can I even say these? I think I might be able to. Start int, or no, this is ending of int, skip int, and loop int. Okay. So my for loop, I'm saying when you start a loop, you really should push loop stack dot append in this case. Well, let's just try it. Ending is ending. Skip is skip. And loop is loop. Okay, I'm pushing those things on the body. They're being appended to the stack. Okay, so I need to pop the stack. Well, I'm gonna have to wait, but that's what's gonna happen. I'm gonna have to pop the stack, increment, or maybe no, I don't necessarily pop the stack. Only down here when it's done. How about modify stack or something? But we'll pick up there. Okay, so my next session then is tomorrow morning, 9 to 11:30 a.m. Eastern time, and I think we'll get the for loops going, and I'm pretty sure we can get the for loops, subroutines, random, and peak. That all seems like we can get that going. So I think at that point we'll be able to test. We'll be able to get this application up and going. Maybe we should do some smaller test ones first. We'll see, but I think we're getting there. So thanks for joining me today. Thanks for the rating party there, folks, and hope I catch you tomorrow or another time. Take care. Bye bye.